So my talk today is called Getting Going with Microservices. I've seen you've probably had a few sessions today on related things. Hopefully I don't repeat too much. We're actually going to be doing a bit of coding together, a bit of live coding, which is always a risk, but should be fun. Right, so just a bit of an overview what we'll talk about today. I'll give a little bit about me. I know there was that update in the chat, but I'll give a little bit about me, about Spaceship, where I work, about the technologies we use. Then we're gonna write a microservice which connects to other microservices, and don't forget about tests. And then I'm even going to follow up with more about testing because that's how important they are. So yeah, about me, I know it said over 15. I'm coming up to about 20 years in the industry soon. So I'm in Australia now. I don't know if you could tell from the accent, but I actually grew up in the US. I went to university there, and I've been in Australia for about 17 years now. I started my career as a Java developer, doing, here and there little projects in PHP, C# across different things like we all do. And I moved to Go about 3 or 4 years ago. I was in a small startup as a side project, and we were using Go, and that's how I learned it. And everybody in the project was sort of learning at the same time. So when that ended, I decided I wanted to get into it for real, and I wanted to code with some people who use it on a day-to-day basis and had experience. So I looked for a job on golang projects or Go projects, and found Spaceship about 2.5 years ago now. And I'm currently the back-end team lead at Spaceship. So that's it for me. About Spaceship, so where I work, I don't know if people probably don't necessarily know about us. We're in Australia, obviously Australian-based. We have two main products. We have Voyager, which is a managed investment fund, and a superannuation product. Within Voyager, we have two managed investment funds. Origin, which is an index fund. If you know much about finance, we don't choose the stocks there, but with Universe, we actually have an in-house investment team that chooses all the stocks for Universe. We have an app. So if we get to the technology side, we have an app with people can see their Voyager balance and their super information and balance. And we have two separate websites. Excitingly, yesterday, our Voyager investment application now has just surpassed 100,000 customers, and we have over $500 million in FUM. FUM is funds under management, so that's other people's money. The company's only about 50 people. We're based in Sydney, and the engineering team, we're about 13 people across front end, back end, and DevOps. From a technology point of view, mainly Golang. The back end, front end uses React Native. DevOps, we're on Kubernetes and the Google Cloud. So that's a bit of an overview. What we're going to talk about today at a top level, microservices. So loosely, microservices in an architectural design which consists of small independently deployable services. They can be in different programming languages. And while not particularly well defined, common characteristics include, they're normally organized around business capability. So instead of functionality, they're highly maintainable and testable, independently deployable, loosely coupled, and decentralized control of language and data. And what that means is you can have one in Go with the data coming from Postgres, let's say, and you can have one in Java connecting to Cassandra, or depending on what the business capabilities of that service is supposed to do, you can use the technology that best fits that. Or if you have a lot of teams, maybe their skill sets, you can send it around there, and it shouldn't matter. About the more specific technology that we're going to use today, grpc, which was initially created by Google, So it's a modern open source high performance RPC, so remote procedure call framework that can run in any environment. It can efficiently connect services in and across data centers with pluggable support for load balancing, tracing, health checking, and authentication. So I've taken that direct from the grpc.io website, which is quite a good website. So if you're really interested, you can go there and have a look. Some basics about it. It has simple service definitions. Like we mentioned before, works across languages and platforms. You can start really quickly, as we'll show today, and it scales quite easily. It's also, you can do bidirectional, one-directional and bidirectional streaming, and you can integrate off pretty easily. We're not going to do any complex stuff today, but just to give you an idea. So the other technology that we're going to be using today is protocol buffers, or protobufs for short. They're basically a language neutral, platform neutral format for serializing structural data. So you structure messages, which are basically name value pairs of fields in a proto file, and then you just compile them. It compiles into the data access objects for your chosen languages. So you can compile into multiple languages at a time just from the one file, and it allows you to populate, serialize, and retrieve that data. grpc services definitions can also be within a proto file, and then the method parameters and return parameter are defined as messages. And then the compiler with a grpc plugin will also generate client and server code along with the protobuf messages. The server code is obviously not the working server code. It's more for stubbing, but the client is up, ready to connect to a server once one exists without any much work. Right, so today, what are we gonna do? We're gonna write some code together. Our goal, we're gonna calculate a unit price for a managed investment fund. I thought I'd pick something that sort of matches up with Spaceship and what we do. We do this, obviously it's a lot more complex, there's a lot more to it, but we're gonna do it in a simple scale. So some questions you might have, I guess, what is a unit price or a managed investment fund? But also, how's a unit price calculated? What data do we need? And where do we get that data? Right, so unit price, I'm gonna sort of repeat myself, but it's the price for a unit in the fund at the time. Now that can change based on certain elements. So when you put money into a managed investment fund, your dollars are converted into a more general unit based on the unit price of when you enter, and when you exit, your units are converted to cash and you take those out. So a unit price is the NAV, which is the net asset value of the fund, and you divide that by the total number of units currently in the fund, and you get your unit price. That's it. It's relatively simple from a high level point of view. Some assets a fund might have, there are different types of funds. You might have stock, you might have cash. A full cash fund would probably be relatively boring, but I guess you could do it. You can have Bitcoin. You can even have property. I think there's BrickX. I think you can buy bricks in property. So you can have property as an asset. Cash can sometimes be a whole bunch of things. It can be, dividends from stocks, interest from the bank account. You could have sold a stock. Maybe you hold a certain percentage of cash permanently, or maybe cash is transient. You get dividends in and then you buy more stock. So that can change, and all this can change each time you calculate. All right, so for today, to keep it relatively simple, our fund that we're building to calculate a unit price for is going to be stocks and cash. So to calculate the value of stock, you need two things. You need the close price of the stock for the day you're calculating the unit price, and you need the position held in each company. Now, what's the position? That's how many you own. So maybe you own 10 of the stock, maybe you own 100, maybe you own 10,000 of the stock. So then you multiply the amount you own by the close price and you get your stock value, and you sum them all together. Cash, we're going to keep this relatively simple, and we're going to assume Aaron's team, who does the cash service, we're going to assume they're doing all the complex stuff related to that. So we're going to ask them their service for our cash value, and they're going to give us, we don't care if it's made of dividends, interest, whatever, we're just going to get the cash. And for total units, same thing, we're just going to query, say, hey, how many units are in the fund? And we're going to use that value. Right, so my beautiful chart, I apologize, I am a developer and I do not make charts. So this is my beautiful chart with the green around what we're gonna build, and that we're gonna go across 3 different other services to get the information we need. Now these services, we don't know if they exist yet. You know, Aaron's team, Ed's team, they're all working. They could be done, they couldn't start them yet, or maybe they're in the middle of building them. It's not going to matter to us. That's what our testing is going to do, so we can work independently. But yeah, I think so. What's our plan? So the first thing that we do need in order to build this, because we don't need those services up, but what do we need? We need a contract. We need the contract of what they're going to build at the very least. So we're going to create the protobufs for all the services. Now, these probably wouldn't be in the same project that we'd be building today, our unit pricing service. You might have either an entire separate project where you build all your protobufs, or maybe they're in the service themselves, and you include the package if you need to connect. But for the sake of ease today, we're going to just include them. We're going to create the contract and we're going to include them in our current project. We're going to generate the code for those projects, including our current service. Then we're going to show how easy it is to get that service up and running and connect to it, and get a value. We're not going to connect through the other services, so that's why we're writing the code afterwards. Afterwards, we'll then show how to connect to other services through the client, and then we're going to use that to calculate the unit price. So we're going to get all that data and we're going to calculate a unit price. And of course, we're going to write unit tests. The stuff that I'm going to show you today is how we do it at Spaceship. One of the things I love about Go is, although there's some guidelines, it's really up to your team to decide how you want to do things. So hopefully I can give you some ideas, some extra tips, maybe some stuff that you haven't seen before, or yeah, we might try that. Or you might say, oh, I hate all that. You might not use it, but that's all right too. All right, to prepare, now I've already done this, and you can see this all on the grpc.io website, but we need the libraries that are going to allow us to compile our protos. You can see them there, and then you need the proto compiler added to your path. But that's pretty much it. So as I said, I've already done this, so we're just going to get straight into it. If the text is too small, can someone message and let me know? There's not much up at the moment, but yeah, just message and let me know. I'm actually going to turn off my video because I'm going to turn the other way and face the screen, and seeing the side of my head is going to be weird. So I'm just going to turn off my video. Okay, so I'll put something up. I've seen it's too small. I'm going to put something else up, and you can tell me if that's better. So, right. So I'm going to create the external services. I'm going to put them in their own packages. So we have cache. I'm going to call it cache.proto. Now, for the sake of time, because if I don't go quickly, we're going to run out of time. I prepared this earlier, but I'll walk through it. So This is a proto file. Okay, now that there's some text up there, is it still too small? How about that? Is that a bit better? All right, cool. All right, so this is our proto file. You can see we have a syntax here. There is a proto 2, but the latest version is 3. You can see we have a package. This is for Go. Some other languages have other requirements. It's basically what's going to give me my package so everything works out all right. Now, as you can see here, here's our service definition. And it's relatively simple. It's like what we talked about with cache. We're going to make a service cache. We have one RPC, remote procedure call. We're going to call it get cache value. Then get cache value request is a message. And get cache value response is the return message. And we define those in the same file below. As you can see, our request does not have any fields. You could technically, if you have a lot that don't have any fields, have a shared like no field request. But we find that, you know, in the future, you might need to add something. It's best just to create it from the beginning. So we almost always create new request and response for every single call. It's really up to you. So then this is a message get response. And what we're going to get in, what we want back is we want the total cache value. Now, if you were to add another message or another field, it would look like this. You can see how they're numbered. If you need to get rid of one of them down the road, you don't want to write something else in that spot. You don't want to get rid of date and then do time or anything like that, because that's what would hurt backwards compatibility. So that's what these numbers really help with. It's like which field and backwards compatibility, but you can really look into that stuff. You also might ask why I'm using string. It's another team decision. You might decide something different, but we've just decided that the best and easiest way for us to transport currency values around is by using strings. You don't have to do that. You can use an int. You can use floats are a bit not great for money when you're trying to be exact. You also see that there's a reason why string works really well for us based on the library we use for calculations. But that's our proto file. And what you can do then is you can use those libraries I downloaded before. I won't go too much into this. This is on the website. You can see, and it explains all the elements. But basically, there's stuff for the regular protos and the grpc. And if I run this, what you'll see on the left here is we get these two generated files. So this one, you can see it shows it created our struct. We don't have any fields in this, so we're just getting these special protobuf fields. But if we go to response, you can see here that we've got our field. And you can see, although it was lowercase because protos are actually snake case, it is not that way once it's generated into Go. So things don't exactly go into the way Go works, sorry about that, but it tries to do as much language-specific formatting as possible. Then you can also see in the grpc version that we've got a client, and it's an interface, and it has our method. And then we have ability to create a new client and call, but we also have a server, and it is also an interface. So these are things we're going to be heavily relying on today. So I'm going to quickly go through. What we need is we also need, what was it, prices. We need our prices.proto. So I'm going to copy and paste this again. A lot of it is very similar. I think the main difference, see here, you could technically have a request where it's like, I want to get the prices for these stocks. We're not going to actually do that today, but I just wanted to show it. So you can see there's a format repeated string IDs. And what that means is basically you'll pass in Go, I guess, a slice of IDs. So our system would, I'm going to get rid of that because we don't need that. But then you can also see something interesting now. We have a map, which is a string to string map, ID to price. Now what I'm going to do in this is each stock would have an internal ID in our system that you'd be able to query everything across the system. So you have an ID to the price. Again, I'm using string for the price. Same, our ID would be goods, but we're going to use string. So we have that, and we're going to generate that. And as you can see, we end up with the same stuff. Then fund. Now with fund, as we discussed, we're actually going to have two RPCs. So it's just to show that you can have two different ones in the same. And as you can see, we just created a request and response. Again, you can find your own way around these. It's just how we've decided it organizes best for us. Units, again, is going to be a decimal, but we're going to do string. And here we have another map. This time, instead of ID to price, we're doing ID to position. Now, position could technically be an int. I'm just going to go along with the same thing and use string here. So save that, and I'm going to generate that. And now we have those files. All right, so those are the contracts of the services we want to get information from. But what about our service? So normally these wouldn't be part of that. Our service may or may not be part of this. You may store it local. You may store it in its own library, but we're going to store it local again. Now my package is going to be called unit pricing. I want this as its own package, so I'm going to actually say PB for protobuf. You might hate that. That's all right. But it's the same. It's the same thing. The only difference is we're going to actually, instead of just using the client generated for this, we're actually going to implement the service side of this. So as you can see, this time I created one called calculate unit price. Again, same thing. I won't go too far into this. It's exactly the same unit price. Again, you can see snake case. And we're going to generate this. All right. Now, I'm actually going to quit. Yeah, I was going to install these, but I think it'll work out fine. All right, so now we can get started. What do we need first? We're going to follow the standard Go format. We're going to create our command folder with and our package main. And then, of course, we need, all right, well, this runs. Doesn't do anything, but it runs. Now what? Well, let's create a really basic implementation of our service so we can test that all the connections work. So I'm actually going to create a Go file here. Package, this time package unit pricing. Now I want to create a struct that will have our methods off of it. And because we're in the unit pricing package, I don't really want to call it because then we're like unit pricing dot unit pricing server. So I'm actually just going to call this server. You can call it service. I mean, naming is up to you. I let the rest of my team do the naming. I'm bad at it. So I'm just going to create that type. For now, I'm just going to leave it like that. Now it's actually a protobuf service thing. I think it's relatively new, and I think it's for backwards compatibility. You include this unimplemented unit pricing server, and it actually allows things to run when you haven't yet implemented the methods. But we're going to actually implement the method, but you have to have that there or you get an error. I'm also going to shorten this because I'm lazy to that. All right. Also, what I like to do, it's again a style thing. I like to create a new method. So instead of just creating the object yourself, you make it really nice and clear what's needed to create a new implementation. At the moment, it doesn't have anything extra, but it's there and it's ready. The next thing that we need to do, if you remember here, the server here is an interface. So in order to implement that interface, we have to implement this method. So I'm just going to copy that, and I'm going to come back in here, and I'm going to go. So we have access to the server methods. Now, I'm a bit pedantic about certain stuff. Everybody has their style, but I like to make these not so long. So I like to do something like that. And this would be PB. All right. If we need to use context, we might name that. We're not going to use the request, so I'm just going to do an underscore like that. It's also nice to return something, so I'm just going to plug in a fake unit price for now. So what we're doing here is we're creating an instance of a calculate unit price response with a fake unit price. And again, I like to bring it down on a line. You don't have to do this, obviously, but I think it just makes it nice and readable. So now we have that. Now what do we do? So it's pretty easy. You need to create a listener on a port. So this is sort of standard Go a bit. What we're doing here is a TCP listener localhost on this port. Now this port could come from a flag that you pass in when you start it up. It could come from config if you're starting them up on servers. Yeah, that could come from multiple places. I'm just doing it the quick way now. And then we need an instance of our server. So we're going to use the new method. And right now there's nothing to pass into that. And then there's a bit of code that allows you to make this work. And basically, you're creating, let me go back here, I'm gonna copy this. Okay, so this is a grpc server, which when passed an instance of our server, the library, that's what the generation library does. It allows us to serve our particular service. This registers our server, and this starts it. And that's it. So if I run again, now it just sits there. Sometimes I just like I normally use a logging library. I'm just gonna use the base library today. %v is anything. It's lazy. If you don't want to think about what type it is, it does anything. So, and now, okay, serving on port 20,001. What does that mean? Well, we can go to, this is a Bloom RPC. It's like a really simple but works really well gRPC thing, sort of like Postman, but for gRPC. So I can find. I'm not sure I understand. Oh, Siri doesn't understand. I can find my proto file, open it up, and it actually does the same thing. It compiles a client behind the scenes. I can click, you can see it has my calculate unit price method. Here, if you had any request fields or whatever, you could add them in there. We don't. Localhost, I have that in by default. And then you just hit play, and there we go. There's our unit price. Name of the tool is Bloom RPC. I can put up the link at the end, but it's pretty easy to find. Bloom RPC, and we have our response. So that's all it takes to get up a service. Obviously, we haven't done anything here. We're not really calculating a unit price, but that's it. That's all the code, and your server is up and running. So now we're going to move on to connecting to clients. Connecting to clients is similarly easy, but still a bit different. So calculate unit price, we're going to need to connect to a cache client. Here, I might actually type that, Bloom RPC. So that's the name of that tool. So it's actually within our server, we're going to need a cache client. So I'm just going to add it, cache client, and cache is the package, cache client. And if we go into here and look, here's that cache client interface. So we're basically having an instance of, well, not an instance yet, but a variable that will connect to that cache client. And now it's in here, we can just do s.cacheclient dot, and then here we go, get cache value. So we'll come back to that. But how do you actually like set up the connection to the client? So that again is in main. It's also relatively simple. So if we look here, we're doing a gRPC dial of a different address. Obviously, this can be configurable. Can other people see the changes or no? Okay, I'll keep going. Can't see it? How about now? Hopefully it'll come back up. But here's the code that I just added. Okay, so we dial. There's actually a whole bunch of options you can add. I'm not going to go through those today, but you basically create a connection, defer the close of that till when we end, and it's really just in that cache package. This was generated. This was generated, the new cache client, and then we have this cache client. Now we actually need to be able to set this, obviously. So if we pass in a cache client And then we set on the server we go back here, and now here we can use that cache client. Can anybody else not hear me? Okay, cool. All right, so we can actually run this, and we can actually still, I'll close this so you believe me that it's not cache. We can still run this, and there's no difference, even though we are not connecting to a cache client. It's not going to matter until you try to connect. Now, there are options where you can set it where it won't do anything unless you connect, but it is possible for it to only care when you connect. So that's how we're going to leave it today. So now, technically, we have a cache client we can use. So we are going to, I know what comes here, so I'm just going to preempt that. But cache client did get cache value. So basically, this wants a context and a request and some options, which we don't use at this time. We want to just pass the context in that came in, because then it follows all the way through the request. If something happens and that context ends, maybe it times out, it'll back out through everything and pull all those back. And then we're just going to do cache.get cache value request. Remember, our request doesn't have any values in it. Again, I'm a bit pedantic. I'm going to do the line thing. It especially helps when the text is really big like this. So we're not doing anything here. Let's handle the error. I'm just going to return nil and the error. You can obviously wrap your errors. You want context, all that. We're going to keep it really simple for today. We're just going to return the error. And then we also have a response. So the response is an object which has cache in it. So if I do cache, I'm going to need error again, because I'm going to use this package decimal. It's a really good package by Shopify, I think. But it's a really good package, and you can create decimals from string, but there is an error on the value. We're going to do get cache, and then I'm just going to copy and paste that. Now we have a cache value. Now to create a unit price, yeah, we actually need a few things. I'm going to create some temporary values, just until we can get those values. And then to calculate our nav, I don't know if you remember from my slide, the nav is cache plus stock value. We don't have any stock value at the moment. It's just 0. So we're going to cache plus stock value for the nav. And then a unit price is the nav divided by the number of units. And then I'm going to change this. I'm going to say unit price.string. We could do string fixed if we wanted a certain number of decimal points. I don't really care for the moment. But yeah, there we go. We have something that connects to cache. If we start that up, it's going to start. But if I come back to Bloom RPC and I try to run this time, we're going to get this error while dialing, because now we're connecting to that cache service, and there's no connection there. So what do? I mean, we shouldn't really be testing this way anyway. You need to have repeatable tests, not manual tests. So I guess it's time to move into that. Sorry about that. That's the last Bloom RPC thing. So hopefully it was enough to understand a bit. Okay, so testing. Right. I'm going to just go back to my presentation quickly and have a quick thing on testing. Testing's pretty important with microservices. I guess it's important with anything really, but with microservices, when you need to fit a contract, it's really good to have nice testing. It would seem complicated if you're connecting to lots of things, but it's actually relatively straightforward. We use a combination of naming with this stuff can get into big arguments. So they're fake, stub, spies. They're all a bit slightly different, mainly stubs and spies. We're going to use stubs today for the service connections. We don't tend to look at code coverage significantly. It's more a base metric of how well we've written tests and where there might be gaps. But we're more concentrating on writing tests that cover business rules, not so much caring about each individual line or branch cover. But the branch cover and line coverage also can obviously show you where you might have missed something completely. So that's where it's important. All right, we're gonna go back to the code. All right, so I'm gonna create a unit pricing test. Now, you should always use this, and I'm gonna have a quick chat about this at the very end as to why. By having the underscore test package, you are testing your package at the level that would be available for, publicly. So the public API, and that's what we want to do. We want to test the public API. All right, so this is kind of a nice way to do naming. So here's our test. What do we need to test? We're going to need an instance of our server. So I'll just plug that in for now. I could use the new method. In the test, I'm just going to do things a bit manually. All right, we have our server, and then we want to call our method. I'm just sort of getting started, starting somewhere, thinking out loud. We don't need to use the response quite yet, but this is what we're calling. And most important for me right at this moment is if we had an error. Now this is a good starting point, but we're gonna have a problem. If I run that test, you're gonna see, you might not be able to see, but there's a panic here, a nil pointer. That's basically because we don't have a client. That cache client is nil, so that's not good. So what are we gonna do? Well, it's an interface. Remember, it's an interface, so we can just stub that out. So I can create a test client interface, cache client. If you see here, it's a little bit, it has this extra like options, and you actually do have to have that or it won't be considered as implementing it. So I'm going to come back, and you can see here it has the context, the request. It has that options that I'm not going to use. And I'm just going to manually return a value. That's not particularly useful. We'll expand on that. But I just want to show this. If I then go into here and I say my cache client is an instance of that test cache client. We're going to run the test, and it's going to pass. We don't really have anything of use at this point, but let's say that was returning 1. We've hard-coded 1 for units. 1 divided by 1 is 1. So we're going to set an expected unit price of 1, and then we're going to check if our response unit price equals our expected unit price. And then we're going to run the test. Okay, so if we look back, I'm using VS Code. It's quite nice. I know a lot of people like Vim, but there's some nice things with VS Code. We can see what code was actually run through. So we can see that this went all the way through there. Now, an alternative we might want to do, instead of here setting this, what you can do is you can set a variable. What we can do here, cut that, c dot get cache value response. And back here, in our test, here we can do get cache value response. We can set it individually in our tests, run our tests, and there we go. That's a bit more flexible. All right, so if we go back here, now if I want to refactor a bit, I have a test, I know what's expected. I can take this is like, if I'm going to get a cache value somewhere else, I'm probably going to do the same thing, right? I'm going to want a decimal. So I might as well create a little bit of a helper method, an internal method, in case, also makes that function a bit shorter. So I'm going to create this helper method where I get the cache value, and it just gives me the decimal and an error. It's just a nice chunk of functionality. And then I'm going to change this to s dot get cache value, passing in the context, and get rid of this. All right, so that's basically the same thing, but what gives us a bit of confidence now, we can run our test and we're still okay. So that was a simple refactor, but as you can see, if code gets more complex, it'll get worse. And it gives you a lot of confidence. All right, so I'm gonna quickly go through all the other clients. I'm gonna put this stuff in because we're gonna run out of time if I don't. So I'm gonna create our other clients, and we're gonna do my line thing. In our servers, gonna have all the clients, so multiple clients. Main.go, it's the same thing all over again. So here's the fund. I've made it a different port, doesn't matter for this time around. Here's prices. And now here we pass in our cache client. We need our next fund client and prices client. All right, those are now all available to us in our calculate unit price. Now we can just keep going. So let's get some units. So I'm gonna go with this same thing where I do the get to the service in its own. Total units is pretty similar to cache with just we're going to this fun client and we're getting total units. But same error, convert units to decimal and return. So now we can come up and we can get units. And I'm going to remove this temporary one. Stock value is still temporary. And we've added that in. We can go to our test. And what are we going to need? We're going to need a fund client as well. This is going to become dirty, so I'm actually going to create a fake, so you can call it whatever you want. And I'm going to move this stuff over. So all I've done is I've moved that into a different file just to be easy to find. And I'm going to create my client. So same thing. Now what's going to go wrong here? There's going to be something that's going to go wrong. I don't know if anybody can figure it out. But so if I set up my units, we're going to do the 1 unit, and we're going to still expect, because we had hard coded a 1 before, and it's still a 1, we're going to still expect the unit price of 1. Okay, so our issue is we're not implementing the interface. We're missing this get positions method. So if we come back here, and I know that I'm going to need this. I'm going to need that. And then if I go into the fun client again, it's nice sometimes to just copy it. I'm going to need this. And this is going to be fun. All right, and we're going to return now. The way that I'm doing the get positions response, you can actually do errors as well. We're not going to get to that today, but just the way that we're faking responses, we can fake errors as well. So we're going to come back and run this, and we're okay. We're all good. And as you can see, we run through that total units. So that's all good. Now stock value. Stock value, same thing. Now we already have our fund, which gets the positions. We're going to need a fake for the prices. I'm going to use that same format exactly. We're going to need our fake for the prices. And I'm going to just preempt with a prices client. But if we go back into here, I'm going to follow this same format. I'm going to create a method. Now this one's a little more complex. So we get, oh, that's not right. So to calculate stock prices, we actually need positions from the fund service, prices, and remember we have that ID that connects the two. So I'm going to range through my positions because those are the ones that are owned by the fund. I'm going to find the price, and then the stock value is going to be my position, the volume of that stock multiplied by the price, but it's going to add to our total stock value. So each stock we're going to multiply, add together, and return that. So this method does the whole bit. So now we're going to have stock value. I'm going to name that value. And these are no longer temporary. We're still doing the same thing. Go to our test, run, and it works. And it's still a stock value of 0 at this time. So now this is fine. We might want to test. Let's change this test success cache no stock. Cache no stock. Now we want to make another test. We have to do all of this, which is a bit annoying. Cache plus stock. And then in this case, we're going to want some prices. And we're going to need a stock ID. So I'm going to actually change some of these values. I'm going to make the cache 10, units 10. So I'm going to say we have 4 of the stock at $3.25. And what this is going to give us as a unit price is actually $2.30. So I'm going to run this. Okay, and it runs. Now we had to copy both of those. That's a bunch of duplication of code. So what might we do instead? We're sort of running out of time. So what we like to do is create a bit of a fixture that does some of this up front, a test fixture. So what this does is it creates the clients for us. So we at least have a base fixture. And then what we can do is we can, at the top of our method, we can create a new fixture. And instead of creating the whole server, we can set the values that matter to us. And then run that. And then each time you only have to do that same thing, set the things that matter to you. So we go here, and it's f.server, and we can run that. Now the last thing I sort of want to cover is there's some other duplication here. If you can see, we're setting a bunch of values, then we're calling this, and then we're testing the result. What you can actually do, and I'm not going to have time to do it today, is you can actually create what's called a table-driven test. Hopefully, if you're experienced in Go, you'll know a bit about that. But what you can do then is in this like repeated code that you use a lot, you just set it up once. And you set up some values. Like this. And then you can create a bunch of different tests that run on the same code. And what it allows for is it really allows for writing new tests quickly. And this would be TC and TC. So you can really, the next test, you just have to copy this, set your values, and move on. Now this allows you to really test this service without ever having to connect to everything and having complete control around the values that are returned to really make the testing simple. I'm going to quickly go back. I have a last point. Testing is really important. I'm going to put my camera on again so you can see how much I mean this. Testing is really important. I can't tell you how many times I've gone to refactor some code and been so thankful for the tests that were written before. They really give you confidence, especially when you're releasing like as you write code. Also, test at the package level. That's the unit of code for Go, and test the behavior of the unit, which is the package, not the implementation. If you feel you really have to test something in particular, it might need its own package. If you don't believe me on this, there's a really good talk by Dave Cheney called Absolute Unit Test. It's at London Gophers 2019. Let him convince you. And my last thing is table-driven tests can really save you a lot of time. Sometimes I don't start with a table-driven test, but it starts to become apparent that you're copying and pasting a lot of tests, and then it might be useful. Well, that was really intense. I hope it wasn't too fast and you learned something, picked up maybe a little stylistic thing, a little tip here or there. We don't have much time, but if you have any questions, I'm happy to stick around and answer them.